Welcome, Factory Live Distillations, Part 6. We talk about post-industrial economies, distributed personal fabrication, peer-based economies in general. The fact is that we're talking about an emerging phenomenon. We found out that talking about the possibilities of a transformative economy is controversial and quickly turns sensible discussion into irrational babble. This is distracting, so to avoid this, we thus accept that we should not talk about religion or politics at the dinner table, nor about transformative economics in general. With this said, we will stick to simply describing our program and letting you make most of the conclusions on societal outcomes. Today we will talk about the program of personal fabrication, which is a state-of-art, flexible production facility that we will house in a workshop that you saw in the last video. In this workshop, we will produce tractors, CB presses, steam engines, just about anything else needed for the infrastructure of globally interlinked communities. As another note of explanation, we keep talking about this, we will do this and we will do that. Well, the proper way to listen to that and interpret that is to include yourself in the we will do this. This is because our fundamental goal is to enable you or anybody else to do the same. How? We're open sourcing all the techniques, then bringing down the cost to the lowest possible for either DIY production as well as developing business models that can work within a market economy. We will help people build the necessary infrastructure first by open sourcing the related tooling and by providing training materials and hands-on courses. The basic goal is to train producers. We will also sell parts and kits. I have not mentioned this yet, but our workshop is open to our true fans. That's one of the ways of giving back, so if you're traveling, you can consider visiting us as part of a productive vacation. We will also be offering master fabricator training, free to fans and at a fee to non-supporters. To make the economics work out, the trainees will actually produce real products as part of their training, and these products can be exchanged for value. This is why you should subscribe with a trivial amount of $10 per month to see this happen sooner rather than later. We're sharing the development risk, and we actually believe that we can gather as little as 1/10,000th of 1% of the world's population, or about 6,000 people, that believe enough in this work to become supporters. Okay, this is a mouthful. We know we're not going to be able to do that by ourselves. And in fact, one critique that we do receive quite a bit is we're talking about all these future things. No, this is not a future thing. This is to be done right now if we find the volunteers. If we find the people, what you see described below is all to be done now, as opposed to piecemeal by our small team of 3 at present. We're using proven technologies, most of which are already open source to a significant degree.
Back to the topic, personal fabrication, flexible workshop. Here's our program listed in logical steps. Install a metal melting furnace with about 300-pound melting capacity per hour. Cast structural steel frame tubing for live track. Cast frame parts for CEB press. Cast steam engine blocks. Use the RepRap 3D open source printer in plastic, both to recycle plastics and to create molds for casting of fine parts, such as bushings and hydraulic motors and pumps. Brief economic analysis shows that our labor in this is worth about $1,000 per person per day in a basic foundry in turning scrap metal to useful parts. We are really talking of reducing the cost of the CEB machine tractor down to the cost of scrap metal plus labor plus fuel, which is only about 2 gallons per hour for this particular case above. Our foundry budget is about $100 to $1,000 for the above case in terms of materials to build the foundry itself. We can use the Babington burner to provide the furnace heat. For structural steel, we may be able to use castings directly, such as for the frame of live track. For a steam engine, we would have to use a lathe to bore out the cylinder. The multi-machine is an existing open source tool. The multi-machine is a universal machining tool which relies on the fact that in any machining operation, either the tool or the workpiece rotates. The multi-machine allows this and thus is very flexible. We are considering an even more simple turning lathe. Combine our rotor mounting that we've experienced with a LifeTrack rototiller with a concrete bed with bolts and add an XY table, tool post and chuck, and we're done. The motor is already available as part of LifeTrack. This covers the industrial lathe. 20 horsepower of motor is enough to turn railcar wheels. We can make our shaft pretty heavy, such as 2 1/4 inch, with bearings from Surplus Center, $21 each. 2 of those, some metal, a $70 cross slide, and for $300 you have a heavy-duty 12-inch lathe. See Bill of Materials on our steam engine page, where the steam engine will be the first application of the lathe. Now, a similar procedure will be used to fabricate a production drill press and milling machine at similar cost. Once again, LifeTrack hydraulic powered. To this, add CNC drive computer numerical control and Linux CNC as the open source control software that's already available. Next, we move on to the torch table for oxyacetylene or plasma torch cutting. Instructables.com already featured a homemade plasma cutter. On our torch table, progress is still lacking, as we're still building the workshop to house this. The torch table is designed for us to cut all the metal from stock, and in conjunction with casting, provides robust fabrication capacity. Now, with the above, we're looking at 20-hour fabrication times for the C/B machine, and 40-hour fabrication times for the tractor kits. This is exciting, optimizing production, open sourcing designs, so that someone could build the same fab infrastructure, download a design, and cast or cut all the same parts. This is distributed manufacturing at its best, and we think it's just around the corner for everybody who wants to do this. Last on the fabrication front, there's electronics. Take a small, very precise version of the XYZ table, like the torch table, and you can etch circuit boards from copper-coated circuit blanks. Then use a micro drill press to drill holes for components, and you can fabricate circuits of all sorts. This is relevant to solar turbine controls, steam engine controls, inverters, chargers, wireless bridges, and many other devices. Also, the micro drill press is used for drilling the itty-bitty hole in a Babington burner, which we aim to use with a solar turbine, steam power vehicles, foundry, and space heating. Good open source 3D drawing software with a manageable learning curve is still needed as far as I know. Blender is perhaps the best one for 3D drafting and modeling, but it's hard to learn. We did our sawmill design with Blender and are now looking for a simpler 3D alternative. Good software for machine control, such as Linux CNC, already exists, but the missing link seems to be the 3D drawing.
Okay, to recap briefly, if we perfect our ability to melt metal efficiently, to print casting molds, and to cast useful parts, then we will have created the capacity of producing about $1,000 worth of value per person per day. Quite significant. We combine that with subsequent computer-assisted machine shop, as well as circuit fabrication, to produce just about anything that another foundry, master fabricator, assembly plant, and electronics fabricator can produce. We can thus make anything from plows to cars, engines and pumps, bridges to wireless bridges, and so forth. We are pioneering not the concept, but the implementation. Once this is done, open source designs become available to everybody, and such a fab workshop itself can be reproduced at the cost of scrap metal plus labor. Then, any person who wants to do this can engage in effective production with minimum barriers to entry. Among the crew at Factory Farm, we call this casting a new civilization at the cost of scrap metal. That's a brief overview for the goals for the next 2 years. Much more details will be forthcoming. So help us make this happen. Give us some useful feedback if this is also important to you.